is our goal. Today, we have the great privilege of welcoming Dr. Alexis Demopoulos, who is not only a neuro-oncologist, he's also a neurologist. And that's going to be my first question, Alexis, because I believe
Sure.
that's unusual. So I'd like to ask you to introduce yourself. Just tell a little bit about your training, your background, and how you're working in GBM now, either with individual patients or on clinical trials or other research. Thank you.
Absolutely. Wow. So thank you for that gracious introduction. It's nice to see everybody. And it's actually kind of cool that we have this way of reaching lots of people, and taking an hour to talk to lots of people makes it a lot easier than spending an hour with each one. So it's very efficient. And I want to thank Jessica Morris and the entire team at OurBrainBank for setting that up. And then talk about me. I don't do that very well. So if I left something out, please feel free to ask questions. So where to start? I grew up in London, Ontario, Canada. She's like, I didn't want to hear where you grew up. And then I went to the University of Chicago, and I majored, like many doctors, in medieval French literature. And I laugh about that, but in fact, my partner here is a major in Russian literature, and our fabulous neurosurgeon, who actually is a really good neurosurgeon. He's got great technique, and he doesn't push anybody into surgeries, which is wonderful. He majored in English literature. And I'm part of this era from the early 90s where medical schools realized that the doctors that they were getting after only selecting organic chemistry majors weren't really all that empathetic and nice and very good doctors. So of course I can harsh on them now, because there's lots of us in the humanities that came into medicine, and we did it because, you know, we want to make people feel better, and we want to make the world a better place at the same time. And it's just interesting that our little world out here in Long Island, which is where I'm based, at the Northwell Health System, one of the largest employers in New York, and we see lots and lots of patients. At the Northwell Health System, all three of us in the brain tumor are all in the brain tumor center are literature majors, because, you know, we're interested in the human condition. We want to make people better. After that, I went to medical school, as many medieval French literature majors do. And I went to medical school by being a little treasonous. I went from the University of Chicago to Northwestern University on the other side of town. And while I was at Northwestern University, I met this great guy named Nick Vick, who loved the opera and was a neurologist, but he was also a neuro-oncologist and took care of brain tumor patients. And he really stimulated me to get into brain tumors, because it was a time when treatments for cancer were getting better and better, and I really wanted to advance that. And I also remember there's this really wonderful moment when I was hanging out with Nick Vick in his office, and a pathologist came up and asked him to look at some slides with him, because he wasn't sure exactly what kind of tumor it was. And I wanted to be that super specialist that everybody comes to and asks for advice. It turns out it means you get a lot of 3 a.m. phone calls, but that's okay. And after training there, and this is going on and on and on, but it's sort of a fun story. After training there, I went to New York City, and is specifically to train with a guy named Jerome Posner, who founded the area of neuro-oncology 35 years ago. When he went into it, there were 2 other neuro-oncologists in the world. And the program in training neurology was 6 months at Cornell, and then another 6 months at Memorial Sloan Kettering. So I really got great education. I did a research fellowship in neuro-oncology, and then I did a clinical fellowship in neuro-oncology. And it turns out that most neuro-oncology programs these days take neurologists as opposed to medicine docs. Not all of them. It used to be that there was this division. There was the Sloan Kettering way, which was neurology and then neuro-oncology. And there was the University of California, San Francisco way, where they took medicine people and taught them a little bit of neurology as well as neuro-oncology. So I came from a tradition of neurologists being trained to do neuro-oncology. And now there's a whole match, and there are over 30 programs. When I was doing it, there were like 5 or 6. There aren't that many neuro-oncologists, unfortunately. Last I checked, which was a couple of years ago, there are about 300 for the whole country. So that's not a lot. That's literally 1 per million. But here we are. And after those training fellowships, I did a little research at Rockefeller University in New York, looking at a thing that nobody thought would amount to anything. I don't know, has anybody ever heard of immunotherapy? So immunotherapy is this fabulous new way of treating cancer, and it actually lends itself well to neurology, because in neurology we'd seen a bunch of patients who had cancer but also had massive immune reactions to their cancer, which had injured their brains. And so we said, oh, there must be some immune reaction where the immune system gets stimulated by cancer to go attack things, and it accidentally attacks the brain. And so we were working on that, and then this guy, James Allison, scooped us and got that silly Nobel Prize and invented checkpoint inhibitors, and now he's at MD Anderson. So that's sort of my background, and that was me talking for far too long. So I'm going to start, I'm just going to go from left to right. Hannah, ask me a question about my background. Ask me how Canada was cold or something.
What did you ask me to say?
I asked you to ask me a question. Yeah.
Okay. So I'm about your background. What inspired you mostly to make that transition from your undergrad to this? What exactly motivated you?
Oh, that's a really good question. I mean, I definitely wanted to help people, and I wanted to be like the person in the room that had all the answers. So that was sort of the ambitious part of it. And then at the same time, I read The Man Who Mistook His Wife for a Hat, and I got really into all the different ways damage to the brain can manifest in how our behavior changes. So I really wanted to have that as part of my life as well. And then, you know, there are just people that stimulate you over time. And one of those was Nick Vick, and the other one was Jerome Posner at Memorial Sloan Kettering. So yeah, and I'm just going to go through the list. So Brian and Susan, ask me a question about my background. What is it that you guys want to know?
I want to know what your experience with glioblastoma in particular is on brain tumors.
Well, glioblastomas have become sort of the bread and butter of neuro-oncologists. So, you know, I finished my training in 2003, which, you know, that was a long time ago. And in 2005, you know, Temodar came out, which is nice. We were already kind of using it in 2003, but we didn't know how good it was until 2005. And since then, I spend most of my day talking to glioblastoma patients and making sure that they're doing okay. So I have more experience than I'd like to have. I wish we had, I remember being at a conference where we were talking about Temodar, sponsored by the company that made Temodar, with a bunch of melanoma people, and the melanoma people, nothing worked, and they were trying Temodar, and it worked a little bit. And now they're all, you know, laughing their way through their clinics because they've got these checkpoint inhibitors that cure people, which are fabulous. And we're still working on that in glioblastoma, unfortunately, which really annoys me. But at the same time, you know, the bar is so low, it can only go up. Damn it.
I have a question. So
and you're next to my list. Oh, yes.
I did a graphic, I think some of you saw, for social media. And I took a quote from a video you did on your hospital website. And you said you had a patient who was 6 years out doing well, and you were elated. Was that a GBM patient, I hope?
That was a GBM patient. And unfortunately, she has relapsed shortly after that video was made. So I totally jinxed it. So I'm sorry about that. Having said that, we've, knock wood, got her under control again. So things are coming along for the last 8 months, 10 months, which is wonderful. And she hasn't progressed since our last treatment regimen, but it was really annoying to see that come back. And you know, one of the problems in this field, which is part of the problems of just doing science in general, is one of the very first patients I ever saw coming out here to Long Island 15 years ago is still disease-free, which is awesome. But I can't take any credit because it turns out that his tumor has this funny mutation that makes you do really, really well. So, you know, you get that news that he's doing well and you take all, you know, a little bit of pride. You know, I'm batting 1,000, that's okay. I'm not batting 1,000, but I'm batting, you know, 100, which is okay. And then it turns out that it has nothing to do with me. It's all science and the basic biology of the tumor. But that's still progress, right? So he's 15 years out. And we do have other patients. It's not so rare as to win Mega Millions that they're 6 years out or 4 years out or longer. It's unusual, but it's not completely out of the question. Yeah. So I guess that's a sign that we should move on from my background to talk about other stuff, which sounds like a fun idea. Does anybody have any questions about how I was trained before we talk about more interesting things? No. I see people shaking their head no. All right. Okay, I'm all ears, Martha. Ask me some more questions on the brain bank. Sorry, Lynn, and I'll keep talking.
I have a question.
Yes.
Which is my favorite question. What is your experience with Optune?
Oh, wow.
There are a bunch of us here are wearing it. I know who's on this call because I've met most of them one way or another, and we're a lot of Optune wearers here, and successful Optune wearers.
Great.
So do you prescribe it? Do you suggest it? Do you recommend it? What?
Okay, these are great questions. So going back to my training, in 2001, oddly enough,
it just started.
A bunch of Israelis came to us at Sloan Kettering. They actually came to Phil Gutin, and they had this crazy device, right? It was completely out of the box, and they showed it to us, and they showed us their little petri dishes with tumor cells in them, and they explode when you put electric fields on either side of it. And it was completely, first of all, they're all a bunch of engineers. They weren't clinical trial experts. And they had written.
And I met them all. I went to Haifa, and I met them all, and I met Dr. Yoram Palti. I mean, they're amazing people.
Great.
Very dedicated. Go ahead.
So one of the things that Phil Gutin said at the time, which I thought was really very clever, he's like, it's out of the box, it's very strange, but nothing else we're doing is working, so let's try it. And the initial trials were done in people instead of chemotherapy. So either, the tumor comes back and either they get whatever the best kind of chemotherapy I can think of is, or they get the Optune, one or the other, not both. And what happened is that the amount of time that the Optune would work for was about the same as the best kind of chemotherapy I could think of, which was very telling. It meant that it was doing something and it was just as good as chemotherapy, and it got approved for that, for recurrence. And the argument against it was, well, our chemotherapies don't work very well, and neither does the device, yada, yada, yada. And then they came out in, I think, 2013, maybe 2015, with the Stoop trial. And Roger Stoop, or Roger Stoop, because he's Swiss, he had put together the first trial with Timidar as well. And Timidar was also met with the same sort of derision and hesitation by the larger neuro-oncology community, because it came on the heels of having tried BCNU or carmustine with radiation at the same time, and that hadn't worked. In fact, people had more side effects than they did worse with the BCNU. So people said, well, BCNU is an alkylating agent, Timidar is an alkylating agent. If BCNU, which is an even better alkylating agent than Timidar, it has more side effects and it's stronger. If that didn't work with the radiation, how can Timidar work with the radiation? But it turned out that for whatever reasons we don't really fully understand, Timidar did work better. And Stoop was the first author on that trial, and that's now the new standard of care. And it really has changed the landscape. I mean, I'm old enough to have seen patients treated before we had Timidar and after we have Timidar, and the outcomes are much, much better. When it comes to Optune, a similar resistance to change was felt. And my attitude is it doesn't have any side effects. We should all be using it. Now, granted, 50% of people get some skin irritation, but it's not like you need an MRI to see that. It's pretty straightforward. So I tell all my patients to use it, and I add the caveat to it that, it, like many things, there's a dose-benefit relationship. Just like when you're going to the Grateful Dead and smoking a lot of weed, if you smoke more weed, you'll get more high. Similarly, if you wear the Optune for, more than 11 hours a day, 18 hours or more, it works better, which really is not that much of a surprise, right? I mean, that sort of goes hand in hand with the Grateful Dead experience. But it can be really challenging for people to do that. And I impress upon people that they're not going to upset me if they decide that they tried it and they don't like it. And that's a very personal decision. Some people just don't want to be reminded of the fact that they're mortal and that they have to wear this because, we're all mortal. People don't want that sort of scarlet letter, which I understand. So I tell everybody to do it and at least try it. And if they hate it, that's okay. And we'll just continue without it. And importantly, we're no longer stuck in a situation where we have to use the Optune or try all these chemotherapies. We can do both. And I mean, since it doesn't have any side effects, you know, we'd normally put it in the drinking water if it was a pill, right? It'd be like fluoride for your brain. But it turns out that, you know, you got to wear it all day long and it's a little complicating. Occasionally it irritates the skin and, you know, you got to be on top of that. But no, I totally support it. One thing to think about with the Optune, which I think is important, is whenever a new treatment comes out, we look at the clinical trials and we analyze them a little rigorously. You know, because people can do a clinical trial and have half the patients on placebo and half the patients with the device, and it's still, the way they did the clinical trial, the way they report their data can be misleading. Similarly, you have to be careful with graphs because occasionally some places, and I'm not naming any places in the Carolinas, publish their results that look remarkably good, even though when you dig down into the details, the graph is actually, this is what happens if you have a tooth infection, this is what happens when you have a GBM. And they're two very different diseases, right? Or they do an anaplastic astro, or they only select people with the mutation that my fabulous 15-year patient has and compare that to everybody else, which isn't quite fair. So when you look carefully at that Stoop trial, there are a couple red flags, which I carefully looked over in anticipation of our conversation today, because I want everybody to know I think it doesn't have any side effects, so why not do it? But wearing the device 18 hours a day was what most people did, and they did that for at least a few months, right? They did that for at least 8 months. Many people did it longer. And they did have 2 patients on that trial who didn't actually have a GBM. And that isn't such a big deal because they had 700 people on the trial, but you know, that they should have excluded them from the final analysis. That doesn't count. And then they had about 1,000 people that they signed up for the trial, and of those 700 did it. And that always is a red flag. Why did they kick out the other 300? Did they carefully select people that were going to do well anyway? You know, you got to wonder about that. But I think overall, Stoop is a good guy, and the trial is reasonable. And it's hard to find major faults with the trial. So I have everybody do it.
Okay. It's been good for me.
Now, that was a lot of information. So does anybody have questions before we move on to other things, or I could ask something else?
I'll just say one more thing about Optune is we actually had one of their representatives on one of these calls recently, and I hadn't actually watched all the videos that they have on their website. And the one that just was incredible was side by side in vitro cells. And the one on the left was being treated and the one on the right wasn't. And you could just, and they obviously sped it up, but you could see in the cells dividing or not dividing right before your eyes. And it was just, I can't imagine anyone watching that and not being convinced. It was so convincing.
Yeah, and I think the science behind it makes sense as well. You know, when your cells go to divide, they split their chromosomes by using these telomeres to pull them from one side to the other, like that. Okay. And then as they're doing that, they need to make weak magnetic fields to pull one set of chromosomes to one cell and the other one to the other cell. You know, when it goes from one cell to 2 cells, it's got to evenly distribute its chromosomes. And that requires weak magnetic fields. And wherever you've got an electric field, you have a weak magnetic field. So it makes sense that the Optune would interfere with that and cause the cell to have trouble. Now, one of the challenges is that we also know that brain tumors make extra chromosomal DNA, so maybe they figure out a way around that. This is all stuff that we're going to have to work on and figure out. Full disclosure, Optune has bought me coffee and chocolates in the past, but nothing in the last couple of years. And I think there's even like, there's some report that they bought me lunch, which isn't true. I paid for my own damn lunch. And I saved the receipts, so anyway. But I still think that I have them right here, actually.
No,
these are my receipts.
They bought me, what was it, raisins and oatmeal sandwiches, or cookies.
Yeah, here it is. La Maison du Chocolat in downtown New York City on March 6th. I paid for my chocolate and coffee, and they didn't have any dessert wine. I would have gotten some of that. And then at Roy's Desert Ridge during the Society for Neuro-Oncology meeting on November 23rd, I think I paid for both of us because it's like a $70 bill. Okay, so on the one hand, you have to be careful because pharma can influence you in ways you don't realize, just like unconscious bias and Black Lives Matter. But at the same time, I'm not in their pocket, although, you have to be careful about that. Certainly the representatives coming on the show are definitely, they've got a vested interest in making sure everybody wears it.
Yeah, and also in the interest of full disclosure, they are a supporter of OurBrainBank, but a lot of people support us, and I know some cancer advocacy groups specifically do not take pharma or device support, but we wouldn't be here having this call without it. So, so we thank them. And they're also super nice. They're just really nice people. I mean, I deal with a lot of people from different companies, as I'm sure you do, Dr. Demopoulos, and some of them they're just out to make a lot of money, and everyone wants to make a lot of money, but they're very compassionate.
Wait, just to add to that, I mean, I've been told, I don't follow the stock market really closely at all, but I've been told that their stock was doing well. I don't know how it's doing now. But that said, they haven't made any money. I mean, for any of us where this device was not covered by our insurance, they said, just stay on it, we'll take care of it. And that's what I mean, I'm on Medicare, and it was many, many, many months of denials. And they said, don't worry about it, just keep going. So I mean, of course they want to make money, but they are the most compassionate people. All they wanted to do was hear from me. When I was there, they wanted to hear from me and how I was doing and how they could make it better, and how they're just incredible people.
And that whole support structure is really wonderful, actually. I don't know, how many people here are familiar with the pharmacy benefits manager at insurance companies? Does anybody know about those? Show of hands? No?
No.
So it turns out your insurance company, maybe not Medicare, but other insurance companies, have pharmacy benefits managers who are frequently given bonuses from different pharma companies to carry their drugs. And that's why you might, go to Walgreens and find out that this drug costs $200 and this other drug in the same family is free, which is a little crazy. And I think ultimately, when you look at the whole system, I'd like for my healthcare dollars to go back into the industry. If they invent something fabulous that works and they are rewarded financially, I'd rather see that rewarded than having it go to my United Healthcare CEO. But anyway, enough of that. Let's talk about brain tumors, not about social policy that I can't do anything about.
I always tell people when we have our strategy meetings and we'll have a room full of brilliant doctors and they start talking, and I say, they sound like college communists. They want to just make everything free for everyone, which I personally love. So getting back to serious questions, let me look at my questions here. Oh, so why is it, and I know everyone here has done their own research, and I've done research for OurBrainBank, but can you talk a little bit about the science behind why some treatments work so well with some people and not with others? I know there's the mutations and there's the types, and it's just, do you see any progress on that, of really learning that and genomic testing and getting it analyzed, all that?
Wow, that's a big question. So, first of all, I think brain tumors, unlike many other cancers like colon cancer, breast cancer, lung cancer, brain tumors, you can't really take the whole damn thing out. Part of that's because by the time we find it, it's already elsewhere in the brain. But the other problem is that you need your brain, right? It's like helpful, it does stuff for you. So brain tumors just in general are always going to be more challenging. Now, there's some brain tumors that do remarkably well with treatment. So those two patients that didn't have GBM that were in the Optune study, they had a kind of a brain tumor called an anaplastic oligodendroglioma. And when I have patients with that kind of a tumor, my focus is on making sure that they don't have side effects from the treatments I give them to keep their tumor under control. Because that tumor is very sensitive to chemotherapy, which is fabulous. It's also very sensitive to radiation, which is also fabulous. But 5-8 years after the radiation, you can have side effects from the radiation. So I try to put the radiation off as long as possible and try other things first. Similarly, there's probably something about glioblastoma that we can subdivide them into different categories. and be able to say that this glioblastoma will respond better to this treatment and the other glioblastoma will respond better to the other treatment. That's certainly the case with IDH mutant glioblastomas. And in fact, the IDH mutation, when we classify something as a glioblastoma, it's based on what we see under the microscope. And there are a bunch of tumors that aren't really glioblastomas. They were lower grade and they progressed over time. And then now they look like a glioblastoma, but they're actually a different kind of tumor. They're the IDH mutant ones. And now we have a gene and a stain that we can say, aha, this is an IDH mutant tumor and you're going to do fabulously well. So we're going to make sure you get all the best care and keep on top of it, et cetera, et cetera. Now, methylated MGMT is also another little finding in the genome of the tumor. It's not actually a genetic test, it's an epigenomic test, which means it's a modification of the DNA. And that's a finding in the tumor that tells us that, oh, this tumor can't repair damage as easily as one that didn't have it methylated. Therefore, any damage I give to it with the Temodar and the radiation are going to do better than if I have a tumor that doesn't have methylation. So we've been able to tease out those two groups. And then with other cancers like lung cancer and breast cancer, there are similar divisions. So breast cancer that is hormone receptor positive is generally more sensitive than one that is hormone receptor negative, so-called triple negative breast cancer. In lung cancer, there's EGFR mutant lung cancer, which tends to occur in young Asian women. And then, as opposed to the very first patient that was found to have it, which was a New York City police cop in his 50s who smoked like a chimney. And the findings of these mutations have actually been very helpful in those cancers for giving specific drugs. So there are drugs that specifically target this genetic abnormality in the tumor that is upregulated, an EGFR upregulation. Similarly, there's a trial in the Carolinas where they target a variant of EGFR, which stands for endothelial-derived growth factor receptor. That particular gene has been targeted by some vaccine trials. While on the one hand, the outcomes were not that better than people who didn't get the vaccine, they also showed that all the tumors that had that particular mutation when they started no longer had that mutation when they were done with the vaccine. So it may be that the vaccine worked exactly the way it was supposed to, but the tumor just was able to grow without it and, cause trouble that way without that target on it. So I think this is an area that's rapidly evolving, and we're not really going to know all the answers. And even though I order detailed genomic testing on all of my patients, it's very rare that we discover anything in there that we can actually act on. Some of the exceptions are a BRAF mutation. Other exceptions include an IDH mutation that wasn't seen through regular testing, but shows up on a detailed genetic testing, and other odds and ends that are a little unusual. In particular, there's a funny kind of syndrome called Lynch syndrome. Has anybody ever heard of Lynch syndrome? Show of hands. No show of hands. Okay. Lynch syndrome is a propensity to have tumors that runs in families. And it's usually with colon cancer. There are very few cases where it's with brain tumors. And those patients have very high mutations in their tumors. So a typical GBM has 1, maybe 3 mutations per megabytes in their tumors. And people with Lynch syndrome have 70 to 318, and they respond very well to checkpoint inhibitors. But that's something that else comes up through genetic testing. We're not sure if that means that our patients with GBM are going to respond better to checkpoint inhibitors with those mutations or not. We're still figuring that out. There were a couple of kids in Quebec that responded very well to the checkpoint inhibitors, a kind of immunotherapy, and they had these mutations. Unfortunately, I just lost a patient who had that mutation and didn't respond to those checkpoint inhibitors immunotherapy at all. And a guy from University of Virginia just published 4 patients like mine where they also didn't respond for adult patients. So we just don't know yet. We'll have to figure that out over time. Damn it, gotta work harder.
Thank you. That was a great answer. And I have a personal interest, and this may not be an area of your expertise, but in the microbiome and how your gut bacteria, both good and bad, affects your life, your everything, your mental health and your general health. And I just recently learned there's a charity called, it's actually not a charity, sorry, it's a for-profit business. It's a pharmaceutical company that's studying this. And they will pay every cancer patients or people with a history of cancer in their family $50 for a stool sample. It's called Poop for the Cure. So have you looked into this at all? I find that really fascinating because maybe that could explain why one patient with the same mutation, the same type of tumor responds to treatment and then the next one doesn't. Do you think, have you looked into that at all?
Oh, this is huge. This is a huge topic. And I think Poop for the Cure sounds awesome. We have clinical trials here at Northwell in Long Island where we collect stool samples from patients on treatment for cancer and specifically to analyze them and see if there are any patterns that we can tease out. Some of them are investigator initiated, meaning that the people at our institution had the idea and they're doing it. Others are from for-profit companies, because if we can make a little pill of poop that you take and everything's fine, that'll be great. I think everybody on the call knows that you have like 5 billion brain cells, right? Isn't that awesome? That's just great. But you have like way more than that in bacteria in your gut. So it turns out that the number of bacteria in your gut outnumber the number of normal human cells in your body. So what is a human anyway, right? I guess we're just carrying poop around with us all the time. It's also true that if you take mice and there's a kind of a modeling of mice. So animal models are useful for studying disease. And there's one where you inject a mouse with a particular kind of stimulation to get an immune reaction against brain proteins, in particular myelin basic protein, which is important for multiple sclerosis. And so you inject the mouse with that, and you have to give it a little bit of something else, which is usually keyhole limpet protein. The keyhole limpet is a little animal that lives at the bottom of the ocean that none of us have ever seen or touched or been exposed to. Neither have mice. And so when they see keyhole limpet, they go crazy. It's like coronavirus. Their immune system goes wild, right? So if you inject keyhole limpet protein with a little bit of myelin from brain, you can trigger the mice into having multiple sclerosis. Now that doesn't work if they don't have any bacteria in their gut, which is kind of wild. And if you tease out which bacteria they have, or you give them bacteria in their gut and then you eliminate it with antibiotics, they also don't have an immune reaction. So gut bacteria actually play a major role in just how we live day to day, and we haven't figured all that out yet. And studying poo is just not very sexy, right? That's why I didn't become a gastroenterologist. I really like the brain, right? It's so much more fun. But it's going to be a big deal. It just has, if there's a Poop for the Cure, I would totally donate some poo. I think that's a great idea. All right, Hannah, you look like you've got a question, or maybe your daughter does. Let me hear it.
So I do have a little bit of a question for you.
Is it about your poo?
It's not about my poop, although my 20-year-old son, if he's overhearing it because he's in the other room, is actually probably wondering about that. But I do have a serious question about genetics a little bit. I was tested for the BRCA gene and a couple other illnesses because unfortunately, in my weird case, my brother passed away from this.
From a brain tumor?
Glioblastoma.
From glioblastoma.
Oh, that is so annoying.
My first cousin.
As well.
Oh, boy.
My first cousin's mom is my aunt, pancreatic, and my grandmother, my father's mother, pancreatic. So anyway, I'm interested. So I know that there's that doctor, I forgot her name, in Texas, and she moved to Stanford. And so so they did the testing for me, whatever they could test, and there's nothing. They found nothing. There's no breast cancer. There's none of that like typical stuff that most of my friends have. So there's something going on, I'm thinking, but who knows? And I also don't want to upset my children, to be honest. I really, really do. And I do have a sister, by the way, who just turned 60 and she doesn't have it. My brother was 56. I just turned 54. But in my brother's case and in my first cousin's case, by the way, their glioblastomas were much different than how mine presented. The location, how fast I was worked on. With my cousin Gail was on both sides of the brain, and they could not operate. This was 2006, and in my brother's case, by the time he got where he needed to go, the doctor wasn't able to remove. The surgeon wasn't able to remove it all. He also had it in his kidney.
Glioblastoma in the kidney?
No, not glio, but another cancer. So what I'm trying to say is he couldn't get the chemo. He couldn't go through the chemo, whatever. Different situations. So my journey here is a little different because I probably would have a mental breakdown if it was just like, oh, let's just, have a brain cancer. But I actually have a little bit of crazy knowledge about this.
Yeah.
And I can present. And in my case, it was pretty much removed mostly. I know that there has to be a little scary something there, but I know that, and I also am methylated. And
yes.
Other little hopeful ideas. And I'm also working with THC and CBD a teeny bit. But anyway, sorry, Mira. So I'm just curious about this. If you've come across this type of genetic situation and what you do with that, have you seen anything like that?
Yeah, so this comes up a lot. And just for the group, let me just address a couple of things sort of across the board. And that is that, number one, this is not a kind of a cancer, a neoplasm, that family members are expected to have. That is to say that there isn't a strong family predominance of it, like there is for breast cancer and colon cancer and gallbladder cancer and bladder cancer, that all go along with this Lynch syndrome stuff. So you guys all know about Angelina Jolie and BRCA, BRCA, and that's, puts you at risk for breast cancer and ovarian cancer. But you probably haven't heard of MSH6, which also puts you at risk for breast cancer, ovarian cancer, and colon cancer. And there are a whole bunch of these, they're called mismatch repair enzymes, that are important for when cells are dividing to correct any DNA errors that sort of occur naturally when the cells are dividing. And if you have BRCA or if you have Lynch syndrome and you're missing MSH6 or one of these other things, what happens is that you can't repair that DNA, and so you end up with abnormalities, and that's autosomally dominant, meaning that Lynch syndrome and BRCA you pass on to half your kids. Brain tumors are not like that. There is a 5% rate of people having a relative with a brain tumor. I have had many patients who've had a first-degree relative, a mother, a father, brother, or sister, who've had brain tumors. And interestingly, there was a study of identical twins where one has a brain tumor and there's a higher rate of the other one developing a brain tumor. But then the identical twins that I've had, the other twin has not had a brain tumor. So that's a little interesting. I have one patient now, I took care of her first her sister, then her brother, and now her. And first her sister had an anaplastic oligodendroglioma, and so she should have done very well, except she went to Iran instead of getting treated by me. But I mean, that's how I like to think about it. So she didn't do so well. Her brother had a glioblastoma, and then she now has a glioblastoma. So clearly there's some family pattern there, but I don't know what it is. Is it that their mother was exposed to the same toxin the whole time? Because we know that if you take a pregnant rat and you inject a drug like Temodar into that rat's belly, that some of the offspring will develop spontaneous brain tumors. So is there something that happened with the mother, and that's why all the children have it, or is there some genetic trait that's being passed along the way there is for Lynch syndrome? We just don't know. Importantly, if you were to strap your kids to a gurney and scan them all in an MRI, they'd all be normal. In fact, we have a series of patients out here in Long Island where people can get MRIs very easily. So, they either slip on the ice, they have a headache, or even some of them had seizures and they had scans that were all normal. And then 2 months later, sometimes years later, they had scans showing a glioblastoma. So scanning all the kids right now wouldn't help us, but the risk for them is basically zero. I mean, it's the same as everybody else, which is the most important thing to take home. There's also a kind of a genetic testing of tumors now that's widely available by a company called Foundation One. And if they did Foundation One on your tumor, then you would see whether or not it had any of these Lynch syndrome genes affected, because that's something that they look for. And foundation one is covered by Medicare, it's covered by insurance, and it's a reasonably good test. There's also a company called, I think, Illumina, that is also trying to get in on the action. They gave me their card a couple of months ago, but I haven't been using them. I've been using Foundation One. And they did not buy me lunch. I paid for my own damn coffee. But I think we don't know what causes these tumors. And unfortunately, that is very, very anxiety provoking when there's an overt family situation. The other thing that's very, sorry, go ahead.
Do you think that there's been more glioblastomas over the years? I mean, because I'm kind of curious also if it's not genetic, maybe it's the environment that we're living in where we actually are surrounded by issues in our, our world, like it's not as clean.
Yeah, so this comes up with a question about cell phones all the time, right? And in a clinical trial, what you want to do is you want to give half the people the thing you think is going to work or cause harm, like the cell phones, and you give the other half nothing, right? And you compare the two after a little while and you see. And so in this situation, we'd have to give half the people cell phones and half the people no cell phones and follow them over 50 years. So do you think we can do that study? We've already done it. Because you can look at what the rate of brain tumors was up until cell phones came out. Like there weren't any cell phones when I was in medical school and in residency training. Now I have 2, right? And so in my family, there are 5 because the kids all have them. My wife has one. I have 2. They're sitting right over there. So it turns out that the rate of brain tumors is basically the same. It changes depending on how old you are. So if you have a big population of baby boomers moving through and they're all over 65, and people over 65 have a rate of brain tumors that's 20 per 100,000 versus people in their 50s who have a rate that's about 3 per 100,000. Then of course, if you have lots of baby boomers, you're going to see a spike in brain tumors, but that's just because you have a population that is older that is more at risk. So it turns out that we don't know what causes them and we can't even blame cell phones, damn it. Is that good? Okay. So are there more questions?
How about environmental factors? Because I mean, are there clusters of GBM? I mean, I've heard anecdotal evidence to that, but I'm wondering if the CDC or someone is tracking that kind of thing. And I know for a fact there's at least one person in our community who attributes the GBM to being at the being on site at September 11th in New York and breathing all that in, which I did that myself. But I had heard of cancers being attributed to that. Obviously, lung cancer is one. But are there other environmental factors that have been determined, or is it still being studied?
So the short answer is no. I have about a dozen patients who were at the 9/11 site that have brain tumors. The challenge is that you don't know what the denominator is. You know that the numerator is, but you don't know how many people were really at risk. And so it's challenging to tease that out. But the short answer is no, there are no environmental factors. Even at Hiroshima and Nagasaki, the rates of brain tumors was not that dramatically elevated, even though we know that people who get radiation are at risk for having brain tumors. So for example, people who have leukemia as children used to get radiated, and then later in life when they're adults, they develop brain tumors, and those have been some of my patients as well. Similarly, patients who get head and neck radiation, sometimes the beams pass through the temporal lobe, and that area can develop a glioblastoma. But aside from direct radiation exposure, and even in situations where there's really dramatic population exposure to radiation like Hiroshima and Nagasaki, we don't see as dramatic an increase as we would blame on any particular environmental factor, unfortunately.
So I have a question on that matter.
Sure.
So I live in Colorado, and we have high radon levels. And I recently moved to an area that has an old uranium mine as well. I know you said it's hard to determine the the environment process, but I really don't have any family history of hardly any cancer. I have the IDH one and the MGMT.
Oh, you have an IDH mutation?
Yes.
Oh, that's wonderful. I'm so glad to hear that.
Thank you. But it just kind of came out of the blue. But with me being in Colorado with the high radon levels, I'm extremely healthy growing up. No x-rays, no CT scans, kind of makes you wonder if that plays a part in it.
So the short answer is still no. But you know what cell phones cause?
Yeah.
Tell me.
Well, don't they have radio frequency waves?
Yes, but you know what their number one medical problem from cell phones is?
Car accidents?
Yes, that's exactly right. And everybody always laughs at that. And they're like, yeah, but it's a big problem. I mean, they're like, the rates are crazy how many people are in car accidents from cell phones. So I think, you really need a dramatic effect to be able to point to something and say that's what is causing it. And we just don't know what causes brain tumors. One interesting thing is this was noticed in the 1950s, that people with brain tumors tend to be the smartest of their siblings. Actually, they billed it as, in the 1950s, they didn't say the smartest, they said the most successful of their siblings. And then now, there's been studies in Finland, because in the 1950s, they say, yeah, that's because you were able to afford a doctor. Because in America, we have to pay for our own damn medicine, which is stupid, but that's the way it is. And then in Finland, where everybody has equal access to MRIs and CAT scans and everything else, they actually also test everybody for their IQs. And it turns out if you have a higher IQ, you're more at risk for having a brain tumor than if you have a lower IQ. So I'm sorry to say, young lady, that it's more likely that you got your brain tumor in Colorado because you're damn smart.
Okay, I'll take that.
Excellent. Good. And it actually makes sense biologically because your brain forms, it makes too much brain, and then it pares it down and makes less brain. And that amount of time to go from too much brain to less brain to sort of set everything up, that amount of time is longer in people who have higher IQs than in people who have lower IQ. So if you're smarter, your brain takes longer to form, and there's probably more opportunity for something to go wrong.
What about stress?
Stress makes everything worse. Look at COVID. What a nightmare.
My husband's convinced that, because I had a very high stressful job and I worked many hours a day, very far away from home. I used to commute really far from Philadelphia, Pennsylvania to New York City every single day. And I worked really long hours and it was a really stressful job. And he's convinced that if I didn't do that, I wouldn't have this brain tumor.
Well, I don't think that's good for anyone. And I hope this big pause on COVID has taught us all that we can be perfectly happy sitting at home watching Netflix.
Yeah. Which brings me to another point.
Yes.
What did you think about, did anybody here see the Netflix special, Lenox Hill?
I did.
Yeah, I mean, it was pretty interesting. I mean, scary, but pretty interesting. But they never mentioned Optune. They sort of gave up. And those doctors were so compassionate and incredible. I'd love to meet them, but they never mentioned Optune, and I was sort of disappointed.
So those are my colleagues, both of them.
Well, they're from Northwell, yeah.
Yeah, and John Bukvar in particular is an incredibly compassionate neurosurgeon.
Yeah.
I mean, and I describe him as being a really good doctor, which is different than being a surgeon. In Britain, doctors are doctors and surgeons are in with the barbers because they used to have the barbers come in to do surgery because they were good with their hands, right? But he's actually a really good doctor in the sense that he's empathetic and he cares about his patients and he follows up. And I've only watched the first episode, so I haven't watched the whole thing.
Oh, keep going.
Chris Amundsen was my patient, and his wife sent me a note the other day, so I guess I should watch the rest of it. The challenge was that even though those guys are really fabulous and empathetic, they're all the way in Manhattan and we're all the way on Mountain Long Island, so we don't get to hang out as often as we'd like. Right. And unfortunately, there are always pressures from above for us to do more with less. And that's a real challenge. And I think you see a little bit of that from David Langer, who's the director of that, and he's really trying to build a competitive neurosurgical program. He's got everybody who's interested in doing it, but they, you know, they need secretaries and they need nurses and they need a place to park their cars. John has done a really wonderful job, and he's been able to carry his intra-arterial chemotherapy from Cornell over to Lenox, and so we tend to refer patients to that. Optune in 2015 it was a great, fabulous thing to do, but not everybody, people hadn't really jumped on the bandwagon right away.
Was that filmed in 2015? That was filmed in 2015? I thought it was like 2018. I don't know why, but.
You know, I was out sick for most of 2017 and I didn't see them doing that. So I think it was filmed in 2017, but I could be wrong about that.
All right, well, that's when I started. I started on Optune in 2018, so whatever. I mean, it was around.
It's been around since 2001.
No, I know that, but not tested. But it was like they gave up on one patient saying there isn't anything else we can do for you. And I'm thinking, no, Optune. I wanted to like scream into the TV, but.
Well, I think it's important to recognize that we don't give up on anybody, right? We're always taking care of them, even if we don't have a tumor treatment.
Right.
Having said that, it's also a little counterintuitive that the time to try a clinical trial, the time to do something that's really the mystery box, you don't know if it's going to be better or the same or even worse than regular treatment. The time to try the magic mystery box is when you're doing very well. And you have to actually be in very good shape to be enrolled in those trials, because if there's an untoward side effect, we don't want to hurt you. So we want to be careful about that. Having said that, we generally always think of something to use even for the chemo, even for the tumor, if it's using chemo like Timidar, even that, you know, for again or for a third time, it's always reasonable. We just, sometimes it doesn't make sense to treat someone because it's hard for them to get back and forth. And the way this country is set up, unlike England, is that if you need supportive care at home, if you need a nurse at home, if you need people to come to the house to help you out, that care, the hospice care, is instead of other treatments. In England, it's with other treatments, but in America, you either do hospice or you do active chemo care. And so we continue to follow our patients when they're on hospice, and we're allowed to do that, but we can't treat them with chemotherapy when they're on hospice. The insurance won't cover it.
Well, that's terrible. We're about to end up our time. Just one more quick thing. Could you, when Tara, you asked the question, you mentioned your specific type of tumor, and Dr. Demopoulos, you said, oh, that's good. Is that because that will respond to treatment better?
That's like my 15-year-old, not 15-year-old, when I met him, his son was like 4 years old. Now he's 19, which is awesome. So, you know, he has that same mutation, the IDH mutation, which, really you don't have a glioblastoma. You've got an anaplastic astro, but that's okay. You're gonna do much, much better than people with glioblastomas, which is wonderful. We like that.
I've got a question.
Ask me anything.
Well, it's actually for Lucas or Kevin or 365078. Since we're running out of time, do you have questions?
English. I come from England.
Great.
And I just would like to know what you feel about dendritic cell therapy.
Oh, that is awesome. Okay, so first of all, last weekend I got to ride bikes with my English cousin, which was a lot of fun. And he told me that when he was in university, there's a student stipend you get in England where the government actually gives you cash to help cover your room and board while you're in college. Is that true?
I don't know. I mean, it's my son who's got a GMB, and he has been having treated by Dr. Nesselhut in Germany.
Okay, so we'll stay on topic. I'm sorry to divert. So in 2003, I started a DC dendritic cell vaccine at Rockefeller University. That was my area of research. And I worked on it for a couple of years, and then I saw that it was going to take 15 years for it to come to fruition. And I decided I would go out and take care of patients instead of continuing that research. And then everybody else that stayed in that research won the Nobel Prize, but not me. Damn it. So I think dendritic cells, a DC vaccine is really kind of cool. And let me just outline for everybody what it is. It turns out that your immune system functions by having specific cells pick up a protein and decide that this is the protein that all of the other cells should attack. So dendritic cells are very important for picking up proteins of, say, coronavirus, or even picking up proteins of a bacterial infection, going back, carrying them back to a lymph node, showing that protein on a particular set of receptors so that everything is stimulated to attack it, and causing the T cell that is specific to that particular protein. There's always one T cell that will react well to that protein. And that T cell then multiplies many times and rushes out and finds any cell that has that protein and kills it. So dendritic cell vaccines are sort of the next wave of immunotherapy that we're hoping will take off. Have you heard of CAR T cells or no?
Yeah.
CAR T cells are basically T cells that are engineered to attack a particular protein, whereas dendritic cells are a little different. What you do is you take the dendritic cell, you engineer it to present that protein to T cells, so then the T cells go out and do it on their own. CAR T cell therapy is now basically established for lymphomas and leukemias, but we haven't been able to get it to work in solid tumors yet. But I think that's coming. And the fact that your son is participating in that research, I think, is fabulous, because figuring out exactly what we need to do to make it work requires volunteers, people that are willing to go in and have that magic box therapy and hope that that magic box therapy works for them. But even if it doesn't work for them, they've gone ahead and done a great service to society by allowing us to know if that particular regimen worked, or if it didn't work, why it didn't work, and then they can go on and encourage the next generation to do the next trial. And that's how we make advances in medicine. Without that clinical trial participation, we'd never do it. And I think people are seeing this more and more with COVID. We see how important clinical trials are in science and donating tissue and your cells so that you can advance the field of medicine. We really need advances. One of the problems with brain tumors is that there are only 20,000 a year in the United States, even less in England, because there are just less people. And those patients are spread out across 50 states with different access to care. Not everybody can get involved in clinical trials, and that's a big deal. Because we need more funding for clinical trials, and we need more people to be interested in them so that we can actually advance the field. And so I don't just do the same thing over and over again and hope for a different result because somebody like Tara has a fabulous mutation that does great, which I love. But that doesn't mean I did anything right. We need to do more research and let me do stuff better.
Okay, well, we've gone over our hour, and I encourage, sorry I didn't catch your name in England, but do you know about, sorry, hi, welcome. Do you know about the OurBrainBank app?
Yep.
Okay,
yep.
Great, awesome. Okay, well, thank you. And also I wanted to shout out to Kevin. Are you still here? That I know you were having, I guess, you had surgery, so you're back home, it looks like.
No, I have surgery tomorrow morning at 7:30 at the James Cancer Center at Ohio State.
Okay, well, good luck with that. I'm glad to see you.
That's why I don't have my cute little Optune on today.
Good luck, Kevin.
Good luck.
Thank you.
Okay, well, thank you. Thank you, Dr. Demopoulos. This was excellent. I think this is our best chat yet. You should have a TV show. You could be Dr. Oz.
Launch a YouTube channel. I'm happy. I could talk about brain tumors all day long, and I hope I helped at least one person. I hope it was useful for you guys.
It was.
Thank you.
I'm happy to do this all the time. Just let me know. And I just, before I go, just one little word, and that is that I met Jessica at a wine tasting party during that year I was recovering from all my illnesses. And she's just a wonderful person. It's just fabulous. So I'm happy to do this over and over again, just to, hopefully Jessica can join us the next time. But I'm happy to do anything for the Brain Bank. It's a great group. Thank you.
Oh, great. Well, I really appreciate it.
Very much.
Thank you so much. Okay, well, I'm going to sign off. Join us next Tuesday at noon. We have a couple of good special guests coming up. We get someone talking about yoga and mindfulness. And so I hope everyone will join us for that, and tell all your friends and download the OurBrainBank app if you haven't already. Okay, thank you.
Okay. Sure, I'm gonna leave so you guys can chat while I'm gone.
I think we're gonna end now.
Okay, bye.
Okay. Bye.
Thanks, bye.
Bye.